And actually, you're doing a little bit of this. All right, let's start by looking at number 21. And like I said, I'm sorry that I not only copied poorly, but yeah. All right. So I'm always trying to kind of underline the keywords that are kind of helping me know what's going on here. And so let's just read the graph. Okay, the graph below shows the number of customer calls the info hotline got during its first 8 months of operation. And so, so we can see the relationship, right? What do we see on our y-axis? What do those numbers represent on the y-axis? On the y? On the vertical? Yeah. The number of calls, right? And then the months are. Does everyone see that? Yeah, no worries. And you might have been trying to say that. So this is right, our y is our number of calls. So right, each point here, what do the points represent then on our graph? Right, in the second month and the third month, right? 300 people or so called. Okay. Now, one thing to note, we haven't gotten to this part in our data analysis section, but does anyone know what this plot is called? I mean, a line plot? Well, it has a line, but it also has dots. I mean, it's a graph, yeah. But it's actually called a scatter plot. And then the line, like it tells us in the question, the line is what we would say is an approximation. Okay, so the line doesn't represent the true data. The line represents the trend that the points are kind of patterning. Does that make sense? Yeah, so it's like the points are actual data. So when you make a scatter plot, right, you start by plotting all your points. And once you have all of your points plotted out, then you look for a trend. And so that's what this line is doing, is it's approximating these next 2 months based on the trend of the first. Does that make sense to everyone? So clearly, right, we're expecting for the next months, are we expecting the calls to continue to increase? Yeah. Now, it might not be the case. I don't know, maybe by month 9, everyone's gotten the information and will be calling more. Anyway. But we'll probably talk about scatter plots more and look at them more. But of course, for our question, we do care about this line. Okay. And so the line approximates the number of calls each month. And so because we have this beautiful straight line and we seem to see some kind of linear relationship, right? As the info has existed, its volume of calls has only increased, right? And so we would expect it, right? You can be pretty confident that it will continue that way in this. Okay, sorry, focusing. So now that we talked about everything but the actual, so then they're saying, what is the equation of the line? Did anyone get an answer for this one? You pick E, right? C. All right. So the thing to know about, right, equations that deal with lines, and like I said, if you want to on Canvas, go to the Monday, Wednesday afternoon class and go to the YouTube playlist, and you can go back and get Mary's amazing lesson on linear algebra. We're going to do a little figure here, but so whenever we're talking about a line in regards to algebra, right? Once again, we have points, right, that form this solid straight line. That's a clear relationship. So because of this line being straight, we can create an equation and basically find any point along that line. Okay? And so in order to do that, right, we have to know x. We have to know the coordinates of the point, right? So all of our linear equations, okay, are going to have an x and a y component. And hopefully you kind of notice that as you work through these problems, that, right, all of these things asking about lines, x and y are showing up because we're always talking about a point that has a vertical coordinate and a horizontal. Okay, so that's the first thing to know. Okay, so on your GED formula sheets, okay, we need to look at the first three formulas. Okay, these are our linear equation formulas. Do you guys want your own copy of this? I go ahead. I know Mary put it on Canvas. We go ahead. So I'll put it in the chat for you guys too. There's a link to the GED formula sheet, and I'll print that for you guys. Okay. All right. So we're going to focus in on these here, and these are our formulas or algebraic formulas associated with linear algebra, right? That line, anything that has to do with a line, you're always going to see y is an x. Okay. So these three formulas are also, right, basically equations. Okay, so there's two ways that we could represent a linear equation. Okay, we can either represent it in what's called slope intercept form or this other form. So slope intercept form is probably the most famous one. Hopefully it sticks in your mind. What does anyone know what we mean by slope? That's another key thing to know about lines, right? Is that the line, straight vertical? Right. So the slope is kind of has two parts. It's not only the direction that the line is moving, either left to right or right to left. So that's part of the slope, and then also the steepness of the line. Okay, right? How steep is it? So this one's kind of middle steepness, I guess, not super steep, but not, you know, if it was like a, you think of the slope of a hill. Yeah. Right. Flagstaff doesn't have any, I think, really small. There's not a lot of steep slopes. There's a lot of not steep slopes as far as I'm experienced. So yeah, good. So in our formula, slope is represented by the letter M. Okay. And so when you look at an equation, okay, a linear equation, the slope, the M will actually be a number, but the X will still be an X. Okay. And so you can see as well, right, that in our other formulas, so we have a formula that actually helps us calculate our slope. However, there are visual ways of doing that too, which might be more efficient than using this formula and this really other formulas in algebra. You're totally allowed to. Okay. So we look at slope intercept form. So the idea of intercept is this chunk here. It's the B. Okay. And this technically means the y-intercept. And so it's talking about where does the line cross vertical axis. And so for this line, because we started at month 0 with 0 calls, right, our intercept is 0. Okay, that's where this line, if we were going to extend it, if we were going to extend it out, right, it would touch 0. Okay. Hey, Teresa, welcome. So yeah, okay. So that is our first way of, right, showing in linear equations. You might see, right, equations say y equals some number times x plus or minus some other number. Gonna be a fun one.
So that would just be annoying.
I know, and I just can't bring myself to code it. I could hear it. I don't know. It's always good to feel like this room is very much a box. All right, so that's our first form of how a line's equation might look. Okay. Our other form, okay, of a line equation is right here. Now this one is called the point. So here, rather than a B, right, an intercept.
Literally accident?
Yeah, because the microphone, I guess, is picking it up. You should set up better audio. Our y and our x are the same. We still need a slope in this form or this equation. But instead of our b, we have 3 points on the line. And that's what x sub 1 and y sub 1, right, is a point that we know on the line. Right, so that's a point on our. Okay. So when you look at our answers, so you kind of have to look at both. But when you look at the answer, what form do they have the answers in? Is it in slope intercept form or is it in point slope form? Point slope form. Okay. So in order to find the equation that matches our line, you need to have a sense of one of the points on the graph. And now, because we have a picture of the line, we don't need to use fancy algebra to figure out our slope. So we know that our answers are in point slope form. So we know that, right? Basically, right? This and this. Okay. What I'm underlining in orange, which I'm sad clashes with my pink, but it's okay. Right, is a point on the line. So, right, they're telling us that maybe it's one of the points on the line is negative 300, negative 3. Is that on our line here?
Your formula is y minus y1. So
yes, it is.
That would represent 3,300.
Thank you. I'm so sorry.
That's all right. That's an easy mistake to make. And before you went all the way down that road, I wanted to stop you.
Thank you so much. So yes, so let's write our formula down so we can refer to it, because otherwise I'm gonna forget. Okay, so we know that our equation based on our answers is in our point, oops, harmony. All right, so this is the form that our answer's taking, okay? And so we know that, okay, so is there a point at positive 300? Yes, okay, right? So there's actually two, well, sorry. Positive 3, so we're looking at this point right here, right? And so choices A and B give us that point here, okay? No, because see, the minus is coming from the formula and not from the point. Does that make sense? Yeah. So the values of X and Y are negative in the formula, but positive on the graph. Yeah. And so, oh, go ahead, Mary.
If you look at D, how it has Y plus 700, that would be a Y1 value of negative 700.
Yeah, yeah. And so right away, right, D we know isn't the answer, but that's okay. All right, so and then is positive 101, is that a point on the graph or on the line actually? It's on the line, it's not on the graph, but it is on the line. So C could still potentially, right, be a possibility too, okay? So then the last thing that we have to decide then is our slope, right? So that's our, okay. So how can we figure out if the slope is 1, 100, or 3? Any thoughts or ideas? No? Okay, no worries.
Moving up, yes, would be 3 to go 1, 2, 3.
Okay, good. So when we sorry, I'm not doing good. The slope, right? Once again, right? It's telling us the steepness of the line. And so when we look at the slope of a line, we look at 2 points. And then we're saying, how much are we rising? And how much are we running? And we divide those 2 numbers to get our slope. So if we look here, if we start at 100, it looks like it rises from 100 to 300, which is a rise of 200, right? And then it runs another 2. So I still don't think I'm doing that right, though. Oh, no, I am right.
Yeah, you're doing it right.
Yeah.
200
Oh,
over-
sorry. Yeah. So, yeah, so we have 200 over 2, right? So we went up 200. Wow. And then we went over 2. So now we can just simplify this. Can anyone simplify 200 over 2? 100. Yep. And so, right, we know that our answer is B.
Can I suggest another way to do that problem?
Definitely.
So if you take and write the coordinates of the 2 points that you're given on the line, 300. So if you'll jot down those coordinates. And then the other point above it that's on the line is 700.
Sorry.
The line that is the correct answer, you could substitute those X and Y values in and it would make the equation true. So the way Curtis and I did the problem would be, we looked at A, we substituted in Y is 300 or 700. So if I start with the first point, if I put 300 in, 300 minus 300 is 0. If I go to the right-hand side, X minus 3, I don't know how far you want to go into that, but the only line that both of those coordinates will make a true statement from is B.
I see that. I see what she's talking about.
So now what we can do, right, is that we have values for X and Y. We can substitute those into here for X and Y. So once, like, for example, where's
And it's a good idea in your point to label X and Y, the 3 and the 300, because you actually use the Y value first. And a lot of students mix up the X and the Y.
yeah. So we're gonna test this point where X is gonna equal 3. Because in this line, right, when X equals 3, Y equals 300, which is this point right here, okay? So I'm going to then insert 300 for my Y. And then for my X, I'm going to put a 3. Okay. So, here's my Y value. And here's my X value. Okay, so I substituted 303 for X and Y in the equation. So we're basically testing the point that we know to see if this makes this equation true. So now we would, decide, okay, 300 minus 300 is 0. 3 minus 3 is 0. 1 minus 0 or 1 time. Wait, why did that work?
Because one of the points is going to work and one of them is not going to work in A.
Oh, I see. So the first point worked. So A could be a line that has our original point, but we have to double check it with the second.
Exactly.
So now let's try our second point out. So now I'm going to use 700 as my X, and I'm going to use 700 as my Y and 7 as my X. All right, so now,
And it's 7 minus 3 on the right-hand side.
Yeah. I was quizzing the students on that, Mary.
Okay.
All right. Okay, so does everyone see how you use the points in your equation choices to test? And you have to do 2 points to confirm that it is the line, okay? Because of course, there can be similar points on similar lines. Shared points on similar lines can share points. There we go. Okay, sorry, math. 400. And then, right, yeah. And so, no, right? So yeah. So I mean, the biggest thing about this problem for sure is recognizing that you're doing linear algebra, recognizing which form or style of linear equation you're going to use, right? And you've got your, right, your formula sheet to help you, okay? And so.
And then I would always say, if you get confused, your fallback position is always to substitute points into equation and see if it makes it true. Because you can actually solve this problem without doing any high-powered algebra. If you fall back to the position, if I know an X, I know a Y, I can put it in the equation. If it makes it true, the point is on the line. If it's false, the point is not on the line. And so if you get confused, always fall back to that position.
Corey?
Figure out what would be Y1.
Because that is the point on the line.
That's the point on the point.
Yeah, so in this formula, the X1 and the the Y1 and the X1 are referring to a point along the line. Okay, so when you actually have the official equation for the line, the Y1 and the X1 are actually values from a point on the line. Does that make sense? No?
I was like, you don't know.
So this is the formula, right? This is kind of like the recipe that then we use to insert, right, what we know to try and figure out what is correct, right? So when I write the equation of a line in point slope form, the only thing that stays the same is, right, you know, the operations and the X and the Y.
And the M.
And the, well, yeah. But the M is going to be a numerical value, right?
Oh, yes. Okay. Sorry. I get you.
Okay.
Sorry.
So I think hopefully this is what you're asking, Corey, and definitely help me understand your question if I'm not on target. But yeah, so the Y1 is the value of one of the Y values on the point. So 3,300 is one of our points on the line. And so when I write the equation of the line and I'm using that point, then the 300 goes into the Y1 spot and the 3 goes into the X1 spot because that's a known point on the line. Did that help at all?
Julie, you might start with the first piece of paper.
Mm-hmm.
Just say, let's pick a point. We want our line to go through point 3,3 or 3,1, and we want it to have a slope of 2. And then show them how you would put that information and write the line. I think that's where the disconnect is.
Okay.
Because what we're doing here looks backwards.
Fair enough. Fair enough.
So let's say we have a line that goes through that we know passes through the point 3,1.
Okay. So, all right. So here's the info that we have. So we need to know one of the points on our line, which we're going to say X equals 1, Y equals 3.
Okay. And then let's say we're going to make that line have a slope of 2.
All right. So,
okay, go ahead. I don't know if you want to sketch that or just show them how then I would write the y minus y1 equals and then show them how you just basically plug it into the formula.
Sure.
I don't know if that'll help or not.
Yes, kind of, yeah. So this is the information we need. This in order to put our line into point slope form, okay? So remember that our point slope formula, y minus y1 equals the slope times x minus x1, okay? And so, right, okay. So I need to insert my values into my formula to create my equation for this line, okay? And so just like I was horribly trying to explain, when you see a linear equation in point slope form, okay, like this, the y is going to stay a y. Okay, then I bring my minus sign down. Okay, but then I go to my points and the y value or the second value in my ordered pair here, my coordinate points, okay? And that number I substitute for my y1, okay? Does this help, Corey? Good, okay? All right, my equal sign is going to come down. All right, now my next piece, right now I need to insert 2 for slope because that's the other piece of information I have to know in order to create this style of linear equation, okay? And yeah, slope is kind of the star of the linear equation. All right, so we'll put in our slope, okay, right? That's coming from here. Okay. And then just like our y, our just regular x comes down. So does our minus sign. Okay. And then we go back to our point. The first value is our x1 value. So I'm going to say 1. Okay. Now we have an equation. Okay. We've taken the formula, we've plugged in the information that we've needed to create this equation for this line. Okay, does that feel all right for everyone?
Okay,
So
and then
now,
the next thing to do is answer the question, is 2,5 on that line? Is the point 2,5 on that line?
you guys want to try that on your own? Okay, so we just made up another point. Is it helpful to see it,
I see it.
Corey? Because I can draw this if it helps. Would it help to draw it? I'm not trying to frustrate you and I apologize. Okay.
I think that's focus, but.
Okay, so this was the point that we knew for sure. And so now that we've got our equation from the information that we have, now we can test the second point and decide with this equation, we can determine, does this point also fall on this same line? Does that make sense? So now that I have my equation, right? So we start with our formula, we plug in our known values into the formula to create our equation. And now I can take additional points and test to see if those points are on this line, okay? So now for my point, like my test point, right? I'm not sure if it's on this line point, okay? I'm going to call this X And I'm going to call this y because I'm testing it. So now I take my equation and plug in this additional information. So now I'm going to replace my x in my equation with my potential point 2. And I'm going to plug in, right, the 5 for the y. I'm going to run this calculation and then, right, see if it comes out to being equal. If yes, then the point is on this line. If not, then it's not. All right, so let's do that step. So now, right, I need to plug in my 5 into my equation for y that I'm testing. And then everything else just stays the same. And then when I get to where the x needs to go in, I'm going to put my x in here. Okay. And now I just need to figure out, right, does this equal? So working left from right. Okay, I need to work inside my parentheses, right, first before I do my multiplying. So 2 minus 1 is 1. 2 times 1 is 2. So is 0.25 on this line here? Yeah, because 2 equals 2. Yep. All right, a little better. We'll practice a lot more of this, Corey. Yeah, it's a lot. It's a lot. There's a lot of moving pieces, and you know, there's always like a visual component and then all of the like algebraic components. And yeah, it's definitely not easy. And for your first day, you know, you took a big plunge, Corey. So I appreciate you hanging in there with us, and especially for me. But luckily, I have Mary to save us. All right. We better continue on, but I think it's good, you know, that we're talking about these things and you guys are at least seeing this stuff, because it needs to at least start sinking in. So if you're not feeling like 100% confident, the most important thing I think if you're kind of feeling like this is whoa, is just what are we paying attention to, right? What, you know, and trying to train yourself to notice what's going on, so you might know what to do. Because yeah, you know, even me, the non-math teacher, yeah, substituting points, I totally didn't make that connection. But, you know, and so I guess the other thing too is as we're talking about these different approaches and ways of going about these problems, think about what feels comfortable for you and really try to kind of apply that as best you can. But, you know, all right. Okay. All right, let's move on though. Hopefully these other ones, now that we've kind of gotten a base, and I know, like I said, I really just kind of plunged you guys into the water here, so no worries. Okay, so then for 22, okay, here it tells us once again which equation, right? So this line, one of these is the equation for this line. So which equation of a line is graphed below? And the hint is telling us to find 2 points on the line. Thoughts?
You can just pick 2 points on one. Figure it out.
Mm-hmm. Yep. Do you guys want to try this one on your own now that we've talked a little bit, or want to think about it a little bit?
We'll use the same equations of both.
Well, actually, if we look at this, I think this is actually our other form. This is our slope-intercept form. So the trick here is to, especially when you have your picture, is to look at your B, okay? So we look at the B values in our choices, because the most important point when we have, sorry, so this is our slope-intercept form.
How do you know that it's
Well, because remember, if we look on our formula sheet, right? Remember, this was the one that we just saw. So there aren't any like you know, like y being subtracted or x being subtracted for anything. So I'm recognizing that it looks more like y equals mx plus b. Yeah, so yeah, if there's not like x's in parentheses being subtracted from something, then it's probably more close to the slope intercept form.
And also if you have a y equals on the left, that's your,
Yeah.
that's always what I would look at. Y is by itself, then use slope intercept.
Okay. So when you look at that, right, we know that y equals mx plus b, okay? M still is our slope, right? And then, like I said, the kind of the most efficient way, I'm pretty confident, right, is that you want to look in your equation and you want to look for the b's, okay? Because that's kind of the easiest point to see on the line, because b is not just the intercept, it is what is the y-intercept. So when x is 0, right, what is y, right? So it's the point of the line that crosses the y-axis. So this point right here is B. Okay. So can anyone tell me the coordinates of B? 0, 1, right? X is 0 and Y is 1. Okay. So B in our equation equals 1. Okay. And we know that because that's where the line is crossing the y-axis, okay? So if you look at your choices of answer, is there any choices where B is positive 1, where whatever x is plus x plus 1? B is C, okay, just C. Is there another place? And this is like annoying, like trickery in my opinion, but what do you mean? But answer D is also a possibility, right? Because this is also positive 1. And what they did here was now they have y equals B plus mx, but because x is negative, well, because mx is negative, then I guess they just thought it was prettier to write it like that. I don't know. But so we know that A and B are not the answers because since there's nothing hanging out over here and we just have negative x, then that means B is 0. And it's kind of silly to say like y equals negative x plus 0 because plus 0 doesn't really tell us much. Okay, so if you see a slope intercept form and there's nothing being plus or minus to your x, B equals 0. Does that make sense? Okay. And then of course we know that B is also not true because, right, the line is not crossing at -1. It's crossing at +1. So we know that our B has to be +1. All right, so then the second thing we have to look for is our M, okay? And the M is basically next to the X. Now, there's nothing next to our X's in our choices. So what does that tell us about M? Or just like we talked about before, what do we know about the slope of this line? It's going down. Do you think that means that the slope is positive or negative? Negative. So that means, right, what's our answer, C or D? D, because X is negative. So whenever X is hanging out by itself and there's not a number next to it, that's our official M, that means M is 1. And of course here, M is -1. 1. Does everyone see that? Because, right, we go always looking left to right and looking at the shape of the line. So if it starts in the left and moves down to the right, it's negative, right? So it's like you're like losing money, right? So yeah, so that's the other important thing to recognize is, right, is this slope positive or negative? Well, it's high on the left side and low on the right side, so that's a negative slope. So then I could also eliminate all of the positive x's, right, because I know that my slope is negative. So yes, D is the answer. And like I said, it's a little annoying, right, because it switches the B and the MX. Yeah.
And the only thing I would add to that, that's the most efficient way to find the answer to that problem. But your fallback position when all else goes crazy is pick some points and substitute them in.
Yeah. And you can do this.
Answer the same way we did on the previous one.
Yeah.
So the input will always be 0.
No. No, only if there's nothing like hanging out in the equation, right? So like answer A, B would be 0 if that was like, if this is the equation of a line, y equals negative x, then that means that the M, the slope is -1 and the B is 0. But here B equals -1, here B equals +1, here B equals +1. You see, do you guys see how to kind of decode the equation and think of it in terms of the formula? A little bit?
Never.
Yeah, I can. If your line goes through the very middle, right? Yeah. So the B is the y-intercept. So you always look at the line. Where is the line crossing our vertical y-axis? Okay. And so in your B, the value of x is always 0, and then y could be infinite possible numbers. So the thing to know about B is that x is always 0 in the coordinate point that corresponds to B, but the value for B is whatever value x is in the point that's crossing the y-axis. I know. It's Stacey, how you doing? So. So like I said, it's like, I know because so, right, M is basically an invisible 1 hanging out next to the X. And of course, we don't need to say 1 times X because 1 times X is X. So once again, if you can recognize that you have a slope-intercept style of linear equation like these 4 choices are, then you begin to look and say, okay, y equals, and then you always look and say, okay, if x is by itself, if it's negative, then m is -1. If it's positive and by itself, then m is +1. Because once again, so you could write this as, let me grab my scratch paper here. All right, so this is our formula, right? And hopefully everyone feels good about the pieces in our formula, right? So that we're going to substitute a value for the slope, and we're going to substitute a value for the y-intercept. Okay. All right. So if we look at our first choice, y equals negative x, okay? Yes, technically, this equation is in this form. It's just because of what the value of m and b are, it just makes the equation unnecessarily noisy, right? Because then it would look like, if I want to make it exactly match the formula, y equals negative 1 times x plus 0. Right? Does everyone, so now, right? This is my m and this is my b. So then if we look at the next choice, y equals x minus 1, okay? Right? Now, if I want it to look exactly like the formula, I equals 1 times x minus 1. Now, positive 1 is my m and negative 1 is my b. Where are you feeling stuck?
Trying to figure out why you just, I wanna know how you got, like, I wanna know how you get the answer, not individual.
Okay.
individual.
Yeah.
I wanna know how you get.
Sure. Okay. All right. So I got the answer because I figured out that the line goes through positive 1, and because it's going downward, it's a negative slope. So D is the answer. Is that better? Worse? Same? So I know that D is the answer to this question because I can see the line, right? I can see where the line crosses the y-axis, which is at positive 1. And because my line goes down, it's negative. It's not positive.
Or be 0 to always end up at 0, like at 0 at.
No, it's only A is where B is 0.
So trying to find it. Right?
Oh, trying to find the B. Oh, yeah. So if you had to calculate B.
Yeah, because
Mhm.
say you started, so the line I did hit 0, you just have to go to 0.
Oh, so if you couldn't see where the line is crossing the
Yeah,
X or the Y. I mean, the majority of lines that you see graphed are graphed with the 4 coordinates. So 0, 0 is always your origin.
But what if you don't have an origin?
Then you are not good at graphing. Like, I'm not quite sure. Like, I don't think you would have, I've never seen a graph where I wouldn't see the axes.
I don't have, like, say that it kind of just stops halfway. So I just making a line that goes towards 0.
So you would have to kind of guess and finish the rest of the line.
Yeah.
You would, well, I wouldn't think of it as going to 0. I would think of it as crossing the Y axis. Okay. And so the point of the line that crosses the Y axis, X is going to equal 0, but the value of B could be anything, right? Yeah. Okay, Corey.
So. Figure what so Y is where M is the X intercept on the line.
M is the slope of the line. So it's the steepness and direction of the line. Okay, right? So this line because it's high on the left and low on the right, it means that the slope is negative. This line, right, we start low in the left and get high in the right, so this is a positive slope. So let me zoom out. So you can really see immediately when you look at the line, whether the slope is positive or negative right away. Does that make sense? Right? So whenever I see a line that is going from upward from left to right, I know that M is always going to be a positive value. When I look at this line, because, right, it starts high in the left and goes downward in the right, I know that it's a negative slope. So as I'm trying to eliminate answers, if I can just look at the right direction of the line and know whether the slope is positive or negative right away. Now, the actual number of the slope, you have to dig in a little bit closer, but once again, right, you can use your graph to always figure out, okay? So you usually want to find like points that are, you know, yeah, and then, okay, so it looks like we're going down 1, right? -1, and then over +1. Down -1, over +1, right? So our slope is -1, right? Because we're going -1 unit every time. Is that better? Yeah. And so of course yeah. So slope, direction of slope is always very easy to visually assess, right? Is the line going up or is the line going down? Especially look at it from left to right, okay? And if it's going up, positive slope, if it's going down, negative slope. So that's the first way you can really eliminate possible choices. And so I could have started with the M, and I'm sorry I started with the B. I thought that would be a better starting point, and I'm learning with you guys. So, all right. Do you want to try and power through these last 3 questions, or should we take a break? Do you guys need keep going? Okay. All right. Yeah, we'll rip the Band-Aid off. Okay. Any final thoughts or comments, Mary, for number 22?
No, I mean, I don't think so, except again, fall back to picking points, substituting them in. That's always your fallback position. As long as you understand that relationship, you can solve a lot of problems without knowing all the intricate math.
Right. So because I found this point on the line 0, 1, I could plug in 0 for X and 1 for Y, and once again, test all these answers out. And if it's
you need to test points.
Yeah, 2 points. Sorry.
Yeah.
So I'd have to find another point, maybe this one here, that's +2, -1. Probably be the next easiest one to work with, or, well, yeah, negative land. Okay. So you guys are getting the hang of it. Thanks for sticking in there with me, okay? So now, once again, right, we can see that we've got this equation of a line stuff. So look at your answers. What form of equation do we have? Is it the slope intercept or the point slope? You look right at our choices for 23. It's the point slope, okay? Now, fortunately, right, we have 2 points, okay? But of course, the one piece of information that we are missing is the slope, okay? Now, we might not need to calculate the slope to guess our answer, okay? So remember our formula, y minus y sub 1 equals the slope times x minus x1. So, oops. Okay. So how could we go about kind of guessing and checking? We have 2 points, and I know that my equation is going to take this form. So potentially, right, these points could, right, be in my equation. Did anyone choose an answer for this one? No? So C, okay, why did you choose C? Mhm.
I don't know, it's hard to explain.
Okay,
I'm not good at explaining.
that's all right.
No.
Okay.
And that's right.
No.
No. Oh.
So once again, I know, right, that if these are points on the line, then potentially, right, a 2 could go, or sorry, a 6 could go here for my Y1, a 2 could go here for my X1, or, right, could have a -3 here and a -1 here. Is there any of these equations that have either of these 2 points in them? A. Does everyone see that?
All the floor.
Yep. So the only answer choice that truly has one of these points is answer A. Does everyone see that? Because remember,
Or answer choice that has the other point in it. And that
oh,
would,
right, you're right. Darn it.
it would be D.
E. Okay. All right. So you chose D? Okay, good. So that's kind of our first starting point, right? We know that probably since they gave us these 2 points, they're going to use one of the points as our X1, Y1 in our equation, okay? And so the first thing to do, right, is to eliminate our choices that don't have those points. Does everyone agree that B and C do not represent the 2 points that we were given? Because remember, in our formula, we have minus. So if we have minus a minus, then it would become a plus. So you can see that answer D uses point A and answer A uses point B. Does everyone see that?
That's what I'm talking about, like the opposite, you know, in a way, because they're looking at it, it's -1, you get positive one.
Mhm.
Yeah.
Mhm.
So you're trying to find, those are 2 different points.
Hi.
Separately.
Okay, can you repeat your question?
Like. Or
So that could be your next step, right? Is that we've eliminated choices B and C. So now we can kind of guess and check with answers A and D. Because we know for sure that A is a possible answer because it contains point B in it. And D is a possible answer because it contains point A in it. Did you want to do a GED practice test? Do you know where Donovan's office is? You know, like when you go back toward where my office is, and there's like an office like right behind the computer lab. If there's a dude in there, right next to our testing room, that's his office. So if you can go find him and ask him if he can help you do that. Because I have to teach you.
I didn't know you got so many people now.
I know. Or you can join us and hang out till 12 and then I can help you. But it's up to you. Cool. Yep. Yeah. So go ask Linda or Donovan. Linda's at the front desk or Donovan. Yeah. Thanks, dude. Good to see you. All right. Sorry about that. So does that help, Adriana? So now, oh, okay. So you don't see how A and D are possible answers here?
And it's saying like, so you plug in point A, and then you have to plug in point B.
Well, so for the point slope form, we only need one of these 2 points. However, because we don't know the slope of the line, we need 2 points on the line. Okay. So with the information that we're given, our equation's going to use one of the points for the equation. Okay, you only need 1 point on the line to do this style of formula. Okay. But to calculate the slope, we need both points. And so if you have, so that's kind of our next our next way that we have to decide between A and D is the slope of the line +3 or +2? Okay. And if we only had 1 point on the line, we couldn't make that choice. Okay. But because we know 2 points, we can figure it out. So there's a couple of ways that we can do this. Okay. We could either use the 2 points and use which is probably going to take more time. You can actually use the formula and calculate the slope, or like Mary's telling us, right? Since we know this point is here, then we can use the other point. So I could put -1 in for X here and -3 for Y here. And then once again, does that make a true equivalent statement? If yes, then, right, this is the line for the equation. If no, then it must be D. Okay. So there's kind of 2 ways to go about it. All right. So let's try, I'm going to put my other point into my A equation to see if it's true. Okay. So Y equals -3 minus +6 times 3 minus 1. Okay. So does everyone see what I did here? So this is point B still, right, at 2, 6. And then I took my point A, -1 and -3, and put those in for my X and Y. Okay. And here's my slope. Okay. Sorry, let me write this down. Okay. So I took this is choice A, and then I took my other point and I substituted those values in for the X and the Y. Okay, now I just have to see if this is true. -3 minus 6 is -9. -1 minus 2 is -3. -3 times 3 is -9. Or no? You okay? Pardon? I know. I didn't mean to kill everyone today. Yeah. Yeah. I shouldn't have called this a warm-up. I should have said intensive linear algebra workout this morning. I should rename it. You're right. And this is definitely stuff that hopefully, yeah, you know, it's definitely stuff you have to see and practice. And then of course, when we layer on that idea of we have choices, so we can use our guess and check and substitute methods on top of any other fancy math we could do, but definitely. So remember that because these negative signs are part of our formula, when our points are negative, they become positive in the formula.
13, so there's 13 right there. Subtract it by 5, so you go 5. Look, 6,
Six,
7,
seven,
8, 9, 10, 11.
So does that make sense?
yeah, I was just trying to see where you got it.
Yeah, so then, you know, yeah, so then, yeah, so then if we plugged in the 2, 6 here, probably we wouldn't get, but yeah, so.
Right.
So yeah, when you plug in your point into the formula, if the value of the point is positive, it'll look negative in the equation. And if it's negative in as a point, and then it's positive in the equation. Yeah. Yeah, yeah, it's because the negative sign is part of the formula, it affects the numbers you plug in afterward, yeah. And will change their sign, basically. All right. Thanks for hanging in there, guys. You're doing wonderfully. Okay. Okay. Anyone get an answer for number 24? Very classic, huh? 48? Oh. You said 48? Okay. Luke is 48? Anyone else get a different answer? 70? Okay.
Because it says that, he's 8 years older than Kate, and he's going 10 years. And combined, it sums up to be 88 with the both together, so. Who says 48 and Kate 40? I mean.
But that would be 10 years from now, right? So then if he's 48, 10 years from now, then he's if he's gonna be 48, 10 years from now, then he's how old now? 38, which is the answer. So you were really close, Adriana. You figured out how old he would be in 10 years, and you just forgot to subtract off the 10. Okay, yeah, so we kind of have two different pieces of information, right? And so, geez, keep choosing the wrong pen. They're saying how old is he now? So we have two pieces of information, right? We know that, okay. So if we represent Kate's current age is where we start, okay? So Kate's current age, right, is the first thing we don't know, okay? But then we know, right, if this is Kate's current age, how could we then talk about Luke 8 years older than Kate in terms of Kate's age?
Let's see.
Yep. Good.
Your
It'd be
vocabulary.
X plus 8.
Uh-huh. X plus 8. Okay. So that's what we know about currently. Okay. Right. And then we know, right, in 10 years, right? So X, right, in 10 years, Kate, right? This is Kate in 10 years. Right. And Luke, right, in 10 years. Okay, so remember, this is Kate's current age, this is Luke's current age, and we're adding 10 years. Okay. All right. And when we're going to add all of those up in 10 years, right, then it's going to equal 88. Okay. Is everyone seeing how to kind of organize the information? So sometimes it's helpful to have it in a table, or like I said, to just kind of take notes, right? And so you're always kind of looking for, where's our starting point? And then how do we talk about other things in terms of our starting point? Okay. So we know that Kate is X years old right now. And that means Luke is X plus 8 years old right now. And in 10 years, Kate is going to be X plus 10 years old. And Luke is going to be X plus 8 plus 10 years old. And those two ages equal 88. Okay. So yeah, these questions are hard to decode. So now does everyone feel like you could solve this equation for X? But then you have to remember, right? Luke's current age, when we solve for X, that gives us Kate's current age. And so, but the answer wants us to tell Luke's current age, right? So we'd have to take our answer to our equation here and add 8. So, right, 2x stop me if I'm going too fast. Oh, did I not do that right? Oh, no,
88 plus 28 is 60.
thank you guys. Pass the test again. So X equals 30. And remember, X is Kate's age. So Luke's age currently is 38. Okay. Does everyone feel all right? So these, it's really helpful to kind of somehow organize the information, okay? So that you can kind of see the progression and hopefully be able to kind of follow along. So we probably could have made like a better chart than my chart. But all right. Last one, guys. We're in the home stretch and then we will cool down, okay? All right, did everyone understand question 25? Nope. Yeah. Okay, what was your point, Nicody?
I mean, for coordinates, right? So
Mhm. But we want our X first.
yeah, there you go.
5, 2. Good. So the answer says, the coordinate grid below shows the location of 3 vertices. So that's our points here, right? And so of course the vertices are like the corners, the part of the rectangle that creates angles, right? And so, what point is the 4th vertice? So you're really just completing the rectangle, right? So 4th vertex, the 4th vertex is right there, right? And so then when we say the coordinate plane, so we always go positive first, so positive 5, and then 2. And weird because so probably on the actual GED, because it's a computer test, you'll probably just have to put the point here, but you might also need to give the coordinates. Yep. All right. Thank you guys a million times over for hanging in there with me today. I know that was intense. And I made you guys bite and chew a big hunk of tough meat. So good job. Any final thoughts or questions? And, if this felt really, really hard and impossible, that's why you're here. And we'll keep working and practicing on these, so that hopefully everyone gets just more and more comfortable. But,
Oh,
Mhm.
so we're doing high school, what grade, what level of being?
I'm trying to decide, like, I can't remember if I did, I want to say that linear algebra was algebra 2. And I took that when I was in 10th grade, but usually it's like 11th or 12th grade, or probably 11th grade math, maybe. I don't know, Mary, you got a guess?
Is he asking when you did lines? and
Like,
equation
like
lines?
what would be the grade level of these questions potentially, kind of? Or
Um,
like,
You could see all of these in algebra 1.
yeah, probably more toward the end of algebra 1.
Like if I wanted to get like a textbook,
Mm-hmm,
because it's see it
sure.
first, instead of just learning
Mm-hmm,
Visual.
it today.
mm-hmm.
If I wanted to get a textbook, what textbook would I get? Basically, what I'm trying to.
Yeah. An algebra 1 book would work. The former teacher recommended this book, and I'm sure there's a 2022 version. But it really hits all of the math skills that you need for the GED. Oh, yeah. So yeah, I like this book because it gives you on the practice, and hopefully that is gonna be helpful to do.
So, the great word is. So, you kind of find B, right? My question is like, what is your pattern? B. You want to go to 0.
You would have to follow the slope. So if this, yeah, so you would have to use the slope to know how to extend the line to see where it's from.
And then.
Yeah.
That was my question, was like, if say we didn't know. Yeah, from there, we're like, well, we don't know where it comes from.
Yeah.
So I was like, so you always want to go to 1?
Yeah.
So
Or the other thing you could do is so if you need to find B and you can't see it, the other thing you can do is plug in. No, because you could solve for Y, but
you gotta find B, so you have to find.
yeah, you would have to know the slope of the line, and then what you could do is use the point slope form.
But also like, so you have to go to 0.
Yeah, and so if you didn't know B and you needed to, what you could do is if you know the slope. No, that wouldn't, and you knew 2 points, but that wouldn't work either. Yeah. So yeah, hopefully if you knew the slope, you could, either project the line so that you can see where it's crossing the y-axis. And yeah, and I don't think, especially on the non-calculator section, I don't think they would give you that kind of line. I would sincerely hope.
I was just wondering, like.
Yeah.
I want to get 0.
You want to see where the line is crossing the x-axis or the y-axis, yes. Because otherwise you would have to, try to solve for y when x is 0 to figure out what b is. Because b is the y value when x is 0, if that makes any kind of sense. All right. I know I didn't officially say this and we kind of got away from it, but definitely like another 5 minutes more of break. And I know we ate up a lot of our time, but I felt like we were doing good work. And yeah, me too. And I think this book's only supposed to be like maybe like $20 max. I feel like it was like only like Although now I forget, like, but if any of you guys are hanging around, this was the book that I was recommending to Corey. If you want kind of your own, independent study to kind of help supplement doing classes and stuff, because you jumped in a very cold pool, but I like this book. And so it's nice. It does cover basically all of the math that you'll need to know for the GED test, which is a lot. And then it also has some practice tests and stuff and stuff like that. And then, it's always nice that they give explanations for the answers, because I've learned a lot from those. And so, it's not cheating or anything. So, so they don't have a lot of information, but at least try to give you, the short and long of things, and then lots of practice. And then like at the end of each chapter are the answers. So yeah, I would say if you want kind of your own personal workbook, and if that works better for you, I'm sure, like I said, there's probably a 2022 version. I was using some of these workbooks in another class, and we discovered that they don't seem to change the problems from year to year as far as what I've noticed. So that's interesting, but yeah. So the author is Reza Nazari and Ava Ross. But anyway, and we've definitely done some practice out of this book, but I don't think we've done any. Okay. No, I mean, we're just gonna go back and keep working on the data analysis stuff. Corey, here's our main lesson that we're working for together. Kind of in the middle right now. See you, Shirley. Have a good weekend. All right. When our warm-ups don't take the majority of class, this is what we're working on together as a class. So we'll just do a little bit of it today. Sure.
So.
Oh. Yeah.
If we just don't think about everything.
Mhm.
The class, like, go through it again. Like, I want to start at the beginning of everything. Right?
Yeah.
I just feel like.
Yeah. Yeah, and it is hard for us. Yeah, it's hard for us to do that because of the way our classes work with our open enrollment. So oftentimes, so I would say right now between the classes, the evening class is kind of in the most basic area of math. I don't know if you can do the 6 to 8 p.m. math class. But then the other thing I would recommend is we also have online lessons that you could do on your own that would also give you attendance hours and stuff. And that way you can hopefully build up your foundation and still get some class. But this feeling like you're not getting anything valuable. And like I said, yeah, it was totally my bad today, choosing super hard questions for everyone. But I think the data analysis stuff that we're on right now is definitely not started for some. So yeah, I'm sorry. So yeah, we're always just kind of moving from unit to unit. And of course, so there's never, like, I would say the only time we do like a full restart is maybe at the beginning of the school year, like in August. But I mean, potentially we have our quarter will end on December 16th. And so our spring quarter will start January 17th. So if I had enough interest or something like that between the students coming to this class or another class, then we could definitely hit the restart button and go back to square one starting in January, potentially, if that's what people feel like they need. I'd be okay with that. Yeah, and it's really hard with how our program's structured, you know, and with student kind of coming and going all the time, everyone's at different levels, so yeah, it's hard to make what feel like good decisions for everyone, and yeah,
It's that used to be like, you know, I was good at math. Today it was just,
okay, well, I mean,
moving on. And I'm just
okay.
like, oh, remember,
Sure. And I mean, you know, the other thing you could do too, if you have the time and ability, we have a lot of videos of previous classes, and so we have those playlists on Canvas. I don't know if you remember this yet. Did Daniel help you get on Canvas?
Oh, yeah.
Yeah, so all of our classes have playlists, so if you were bored and wanted to, you know, try and learn some more math, you could maybe go back through and look at some of the previous lessons.
So basically my best bet is find that maybe. Okay.
Yeah, and I mean, you know, I would say so, and you know, you're always welcome, sorry, Susie. You're always welcome to come in during our afternoon times and work with Daniel or I one-on-one. We can work through that with you.
I was just gonna schedule. I just can't work.
Oh,
I worked all night.
yeah,
All
okay,
our shit.
dang, that's hard. Yeah, we can definitely try and, you know, kind of play it out and figure things out as best we can. And yeah, thanks for sharing. Okay,
So, you want to learn, so, wouldn't it be better to attend for education?
probably. That was what that was one of the options I had. So one thing you could do is, if what we're working on in class feels too far above your level, I can give you some online lessons and you can work on that. Or you could work in the computer level. That's even so you don't have to deal with me.
Yeah, I'll deal with it.
Okay, but yeah, there's definitely alternatives. I definitely want you to feel like you're getting good stuff, and yeah, I mean, jumping in after a night of work and a new teacher and lots of a funky math. Yeah, you're doing amazing, I think. All right, so let's just for 10 happy minutes here. And so, yeah, the other thing to remember, and I totally forgot to say this to you guys, so it's good that we're doing this. So we've talked about this in some other classes, and actually, I guess I did mention this on Tuesday. But we don't have our regular classes next week, so we won't meet on Zoom and we won't meet as a group to work on our lessons. So once again, Corey, if you can still come in like on Tuesday and Thursday morning next week, I can work with you one-on-one with some more foundational stuff. So we won't meet formally for class, but if you have time to come in onto campus and work, you can. A couple of you folks are going to progress test. So that we won't meet for class, but we will be around if you want help or need anything to study. Okay. Yeah. So cool. All right. So this is our data analysis unit that we've been working through. And so we ended on Tuesday, and of course, we're not going to get super far today, but that's okay. So we ended on Tuesday focusing on the mean. Hopefully everyone feels confident about how to average numbers and calculate the mean, the exact middle of our data set. Okay. And so we add up our data and then divide it by the total number in the sets. And that gives us our mean or our average. Okay. So the thing we were learning about using mean to talk about the middle of our data is sometimes we have outliers, which, make our mean not very representative of the numbers in our data set, okay? And so, right, we ended by looking at these other points, right, and saying, okay, here's, right, the outliers, which make my mean kind of different than what my kind of estimate would be, okay? So everyone kind of remembering that. So when we look at a set of data, if we have outliers, then the mean might not be the measure we want to use, okay, to talk about where the middle of the data is. It tells us our exact middle, but it doesn't really tell us where we are generally, okay? Is everyone remembering that from Tuesday for the most part, who was here?
Yeah.
Okay. Yeah, the outlier is going to be either significantly larger or significantly smaller than the other numbers in the data set. And so when that occurs, it affects our mean. It'll either inflate it too high or, right, inflate it too low so that it's not really representing the middle of the points that we have here, okay? So with that said, then we have two other measures of central tendency that we might use instead, okay? And we've already talked about these, but it's always good to review. And I think everyone's doing pretty good on this. And this is definitely one that's way less intense than what we started with today. All right. So we know that the median is the middle value of a set of data. So, right, differently from the mean, which is always going to be kind of generally not a number within our data set, it's going to be like that, right? Our median is a number that comes from the numbers we have, right? So all we need to figure out the median is our numbers, okay? So then this is the median is our measure that we should use when we have that outlier, excuse me. So to avoid a misleading typical value, which is our middle, the median is often used when some values in a set of data are extreme, okay? So once again, if we looked at our data from Tuesday, right? Our median, well, that's not a good option. We always have 4 pieces of data here. Okay, so we look here, right? Our median is 85, right? Which is closer to our common sense average than our mean because of our one super high price here. Does that make sense to everyone? Hopefully a little bit. Good. So then, right, to find the median, wow, okay, we sort the data from smallest to largest, okay? And so the key thing here is, okay, so the median is easy when we have an odd number of data values because it's just the middle number among the values, right? Like we see here. Okay, right? So we have an odd number, we have 5 pieces of data. And so the middle number among the 5, right, is our median. Okay. But, okay, if we have an even number of data values, the median is the mean of the 2 middle numbers. So then we find the 2 middle numbers, add them together and divide by 2, right? So we're just averaging those 2 numbers. So I think you see it right here, okay? So if you have an even amount of data, you still, right, do the same process. We're going to sort it numerically from largest to small, or from largest to smallest, from smallest to largest, and then we find our two middle values and calculate the mean. Okay, so for this data, our median is 29, which is not one of our data values, but it is the exact middle of our data. Does that make sense? So that's kind of the kicker with median. And so I don't really want, well, let's see. We'll go ahead and just try exercise A here at the bottom. Just do 1 and 2 at the bottom, okay? So find the median in each of those data sets, okay?
I'll be talking now. But the class was ended and then.
So hopefully everyone at least found, right, the middle value for 1. 2 might not have, well, maybe in 2 minutes we can figure it out. So 1, 2. So 4 foot, 11 inches. So 12 inches. So for number 2, the median should be 5 feet exactly. What I got. So you just, for your even sets, find your 2 middle numbers, add them together, divide by 2, and that gives you your median. So 4 foot, 11 inches plus 5 foot, 1 inches gives me 9 feet, 12 inches, or 10 feet total. Everyone feel good about that? And then divide by 2, it's 5. All right. Okay. Were you using feet and inches or were you using decimals?
Somehow.
Okay, no worries. We can talk about these more next time. Now, the other quick thing, guys, the week after Thanksgiving, we will have class and we will continue with these lessons. However, Mary's gonna take the reins for that next week. So we won't actually, like, it'll be like Zoom only because I won't be here. But anyway, I'll keep you guys posted on that and everything. So no class next week. And then the following week will be Zoom only class with Mary leading. So that's the week of the 28th through the 1st. And then Anthony, Adriana, I'll see you guys on Tuesday at 10 for your progress tests. Okay. Do you guys want study materials? You just want to? All right, let me get those for you. Okay, cool. All right, thanks, guys. Take care. Have a great weekend. Let me know if you need anything. All right, everyone on Zoom, okay? Need anything? Terry, Sam, Curtis?
I'm good.
All right, night, guys.
Thank you.
Bye.
Happy holidays.
Thanks. Yeah,
Holidays, really few.
for